Hi, everyone. I'm going to just jump gears quickly and go back to some stuff that Kath talked about. So I've been working with the MWA and looking at how the beam patterns or the all-sky sensitivity of each of the receiving elements or tiles affects EoR signs or, in fact, other signs. So what we did a couple of years ago was use satellite measurements to kind of build up all sky maps of the MWA beam, which is the central circle in the top row of 3 beam maps. And to the left of that, you see the FEE or fully embedded element beam pattern, which is the cutting edge simulated beam pattern, which is used in all our calibration softwares. And the question I'm trying to pose is, what effects do kind of distorted beams have on our analyses? And these beams are often distorted by environmental factors like bushes or kind of dipoles slowly dying with the harsh conditions on site. And so what I've done is kind of used a minimization technique where we have 16 free parameters in our FEE model, and I try to optimize the values of these 16 parameters to best match our satellite maps. And that's the result of the beam map you see on the right, where you kind of reproduce the loss of the nulls and kind of the fading of the crispness of the FEE model. And so we're kind of starting to reproduce the satellite map or closer to the satellite map. And we're working with collaborators to kind of move in the 16 dipole parameters into our calibration software. So the 2 projects that come out of this would be to now simulate an MWA array with these deformed beams and understand their impact on the 2D power spectrum, which is our which is how we analyze the epoch of reionization signal. And the other thing I use it for is also to see the impact on polarized studies, which is the bottom panel. What I've kind of showed right now is that
I'm sorry, we have to move on. Could you wrap up?
Yep. Okay. So if any of this looks interesting, just chat with me on Slack. That's it. Thanks.
Sorry. Thanks, Aman. All right. And our next speaker is Mike Kriele, who will give a fancy animated talk. So go ahead and take it away.
Hi, I'm Mike Kriele, and I will tell you something about mapping the diffuse low frequency sky using spherical harmonic all sky imaging. So basically what we do is we take the engineering development array 2, an SKA low prototype wide field interferometer array system, and we then leverage Earth's rotational symmetry in conjunction with spherical harmonic basis functions. This allows us to perform something we call spherical harmonic transit interferometry, where we will image the sky over a full sidereal day. And as a result, we get what we call a dirty image, which we then can clean using like the point spread functions of our system to get our final image. Furthermore, we can also use a prior to fill in the missing spots on the sky and better constrain our data, like in this 159 megahertz map we recently submitted. Of course, we won't stop there, so keep an eye out for future publications where we cover additional methods, as well as multiple frequencies of diffuse sky maps. Thanks.